Hello everyone. If you are watching this video, it seems you are ready to dive into learning about Java collections. I hope that by the end of this video, you will have a great understanding of at least HashMap. So let's take a look at what collections are available. At the top of all collections is iterable. Next is collection. This is the basic interface for all collections and other collection interfaces. From it, we can build 3 conditional vectors, and these will be interfaces. List is an ordered collection that allows duplicates among values. A characteristic of list is that the elements are numbered, and they can be accessed by their index. Well, you are probably familiar with the index queue translates to. Queue. In a queue, elements are stored in the order they are added. The queue represents the functionality for a double-ended queue. Set, unlike a list, describes an unordered collection in which there are no duplicate elements. Set corresponds to the concept of a set in mathematics. Sorted set is an extended interface of set for creating sorted collections. Each of the interfaces is provided with additional classes. UList is an array list, a simple list of objects. Linked list is a linked list. Vector is an ordered list of elements, an outdated equivalent of array list. Stack is a structure that implements the storage of elements based on the principle of a stack, such as a stack of books. There are push methods, which are push, and pop methods, which are pop. Queue includes priority queue, which is a priority queue. Array to queue is a class of a double-ended queue where we can perform insertion and deletion at both the beginning and the end of the collection. And of course, set and hash set are a collection of objects or hash sets, where each element has a key and a unique hash code. A linked hash set is a linked hash set. A tree set is a set of sorted objects in the form of a tree. This is all great, of course, but the video was titled HashMap, and we don't see it here. We don't see it here because map, unlike other collection interfaces, is not a subclass of collection, but at the same time, it is part of the collection framework and is designed to create data structures in the form of a dictionary, where each element has a specific key and value. The implementation of map includes HashMap, treemap, and linked HashMap. HashMap is a data structure in the form of a dictionary, where each object has a unique key and some value. Treemap is a data structure in the form of a tree, where each element has a unique key and some value. Linked HashMap is a data structure that stores data in the form of a linked list of elements. The elements are arranged in the order in which they were added. You often come across hashtable. It is an equivalent of HashMap. It is simply an outdated collection from older versions of Java, left for backward compatibility. Everywhere we remember the slogan of Java, write once, run anywhere. Well, here we are at the main topic. This is the HashMap. The HashMap is one of the most widely used implementations of the map interface, which stores data in a key-value format. Under the hood, a HashMap consists of an array, a table with elements of type node. Each node represents a linked list of buckets that contain 4 fields: hash, key, value, and a reference to the next node. The HashMap has 2 parameters that affect its performance. This is the initial capacity, and load factor, Capacity is the number of segments in the hash table, meaning the length of the array, which should be a power of 2. By default, it is 16. The load factor is a measure of how full a hash table can get, before its capacity is automatically increased. When the number of entries in the hash table exceeds the product of the load factor and the current capacity, the hash table is rebuilt. By default, the load factor is set to 0.75. How does the addition of an element occur? The key is checked for equality with null. If this check returns true, the method putForNullKey will be called with our value. Next, a hash is generated based on the key using the hash method, which takes the key as an argument. This method returns an integer through mathematical operations. This number determines the position in the array where the element will be added. If the cell is empty, a node is created in which the key and its value are recorded. If the cell is already occupied, the key is checked using equals. If the key is not found, a new node is created, resulting in a linked list. This can happen because the hash code of different objects can produce the same value. If the keys match, the old element is overwritten by the new one. Objects with null keys are always stored in the 0 index of the array. Ideally, each bucket should hold a small number of objects, or better yet, just one. This gives us constant access speed to the object, but we all understand that collisions are inevitable, so one bucket can grow to a large size, especially with a poor implementation of the hash code method. This, in turn, leads to a deterioration in the search time for this object, which is why a special protective mechanism was implemented. When the linked list grows to 8 elements, it transforms into a balanced tree. This transition provides us with efficient access time to the object. Now let's see how we can interact with this hash map. So we created a test class, and in it, we will create the main method. Now we can create our first hash map. Yes, the syntax might be a bit strange, but it works. To demonstrate this, we will simply add an element to this map. Let's do it. Just print it to the screen. Let's run it. As you can see, everything is working. But as you can see, the compiler is asking us to add parameters. Who are we to argue with it? Moreover, Java is a typed language. Therefore, we make some minor corrections. Let's add the necessary missing string and integer. In older versions of Java, you might encounter a notation where the type is also specified within the same quotes. Starting from Java 7, this has been simplified. Apparently, I'm not the only lazy one. But what you should pay attention to is that when specifying types, you cannot use primitive types like int or double. So if I try to write int, it seems to work, but it immediately gives an error that it does not work with primitives. So let's say your map will contain employees and their unique number in the database. It is clear that you will likely have a separate class called employee where all of this will be, but I think this will be a good option for an example. Let's rename our map to a more meaningful name. In general, giving meaningful and clear names to variables is usually considered good practice. Let's say, for example, employees map, great. Now we need to add the first employee. To do this, we simply refer to employees. And here Java suggests the put method since we specified that the key will be a string and the value an integer, which forms our pair. Therefore, we must pass our key, which will be John, probably the most commonly used in all code examples on the internet. Let's say it has the key 1. Let's add some identifier like 4 or 5, and also add a couple more colleagues. If you are familiar with other programming languages, seeing these brackets, you will surely say, this is an object. Well, yes, but in Java, objects are instances of a class. But what's interesting about that? We know that code executes from top to bottom, and it seems that our employees should have been added in the same order. But no, if you need to maintain the order of insertion, then you need a linked hash map, as a hash map does not guarantee that the order will be preserved, and only that each key will have its value. Although, with one caveat, this value can be no, just as one of the keys can also be no. But how do we get the value from this object? Of course, by using get. And yes, you can only directly obtain the value by the key. If you need to do the opposite, then it can only be done by iterating through all the values and then finding its key. So we won't reinvent the wheel and we'll call employee get John and immediately output it. As you can see, we had John with the key and the value 1, 2, 3, 4, 5. In fact, that's what we got. But let's say we have a large list of employees, and we just need to know if Jane is there. For this, of course, there is a separate method, or rather two, that return true or false. The method is called contains. It can be either k or value. For example, and place contains k. We are looking for whether we have Jane, and we run it, and as you can see, when we first search for Jane, we have it, and it returned true. When we don't have that key, we got false. The contains value method works exactly the same way. We take one of the keys, and just a little less. Again true, so we have that value. False means we don't have that value. This might be useful for you, for example, to check before adding a new employee, since the put method is very persistent. If we add Jane again but with a different value, it will overwrite the existing one. Let's take a look. Let's display our employees on the screen. Then, we will add Jane again, but this time we will use all 9s for her number so that it stands out. We will display it on the screen once more. We had our track. Then we added the put method. He saw that such a key existed, and he was completely fine with it, so he just replaced the value. But the developers certainly considered this option as well, and there is a method called putIfAbsent for it. It will check if this key already exists, and only if it is absent will it add it. If the key already exists, then nothing will happen. We check that our employee Jane still has her original number. You can always check whether an element has been added or not, because if the operation is successful, it will return null, as everything has been added and there is nothing to return. However, if the record already exists, it will return the value that is already stored in the database. Since we already have this value, it has indeed returned as expected. To replace something, there is, of course, a separate method called replace. For example, let's change someone's ID. Replace. Note that there are two types of replacement, and they have different return value types. We can pass the key for which to replace and provide a new value. We can also pass our key, the old value, and the new value. If no such value is found in the database, then for the second parameter, we will get either true or false. In the case of the first parameter, it will return the new value that we changed. Let's take the replace method, for example, with two parameters, nothing John, and we can change it to 5 for 3, 2, 1. We perform the assault, and here we need to enter the old value and then the new one. While this line is commented out, the old value that was replaced is displayed. In the case where we move 3 elements, we receive a success message. The value for this element, John, has been replaced. Let's move on. If you can add, search, and modify, then of course you can also delete. Method remove, for example, John. Let's check. This employee is no longer in the map, such as John. We will also not overlook entrySet and keySet. As the name suggests, they return either a set of keys or a set of values, meaning pairs of key and value. Let's consider a small example. We will create a set to store keys, set of strings. Great, that works for me. Employee set, we are accessing our map. We take the keySet to see what we have inside. Intelligence suggests that we use a for loop to break down what will be inside, and we will simply print each element that we obtained on the screen. That is, we access our original map through the map method, since all the keys are stored here, namely our John, Jane, and Bob. We can call it each time with a new key. Here are all our keys that were inside. This is the entrySet. As I mentioned, we also have the entry map. It's very similar, but since this is a set from our map, we can also iterate through each key value pair. We take a separate entry from our employee set too, and of course, we will display it on the screen. Great, it already suggests it. So we display each entry, select its key, and for that same entry, we take the value, which we can comment out for now. We see all our key value pairs. Here is our Bob, here is our John, and here is our Jane. If you are just getting familiar with collections, it might be difficult for you to understand and remember all the methods. But everything comes with practice, and of course, pay close attention to the hints in the compiler. The main thing to remember is that a map always contains a pair of keys and values. Key values can be anything, but they will always be together. If you get the hang of HashMap, then 3map and linked HashMap will no longer be a problem for you. The main thing is to choose the right class for the right task. That's all for today. Check out our other videos. If you have any questions, we look forward to seeing them in the comments.